In this video, we're going to talk about derivatives of exponential and logarithmic functions. So let's say we have y equals e to the u, and the derivative of y, which is y prime, would be u prime e to the u. So let's say, for example, you have y equals e to the x. So what would be the derivative of that? The derivative of that is, in this case, the u is x. What's the derivative of x? Just 1. And the a will be just e to the u, which is x. If y equals e to the x squared plus 3x, now in this case, u would be x squared plus 3x. So what is u prime? U prime is 2x plus 3. So derivative of that would be u prime, which is quantity 2x plus 3, times e to the u, which is just x squared plus 3x. Let's say you have y equals a to the u, where a is not equal to 1 and a is greater than 0. So the last example, the base was e. Now it could be any real positive number as long as a is not equal to 1. So when you take the derivative of this, it's going to be a to the u times natural log of a times u prime. That's how you find the derivative of exponential function. So let's do some examples. So let's say you have y equals, let's say, 5 to the x. So what will be the derivative of this? Derivative will be just 5 to the x times natural log of 5 times what is u? It's just x. What's the derivative of x? Just 1. So this will be the derivative of y. Now what if y was 4 to the power of 2x? What's y prime? It's going to be 4 to the power of 2x times natural log of the base, which is 4, times derivative of u, which is 2. So you could say that the derivative of that is 2 times natural log of 4 times 4 to the 2x. So how do you find the derivative of this? The derivative of that, this is y prime, or dy over dt, derivative of y with respect to t, is a derivative of 2t, which is 2 to the power of t times natural log of 2 times the derivative of t, which is just 1, minus the derivative of that, which is minus 12t squared. So this will be the derivative of y. If you have y equals natural log of u, the derivative of that will be u prime over u. So for example, let's say you have y equals natural log of x. So what will be the derivative of that? Derivative will be, the u is x. What's the derivative of x? 1. Over u, which is just x. So derivative of natural log of x is 1 over x. What if you had y equals natural log of x cubed? Derivative is derivative of x cubed, which is 3x squared, over u, which is x cubed. And you simplify it, you're going to get 3 over x. Also, you could think of it as, remember a property of natural log, when you have exponent, the exponent goes in front of natural log. So we could write this as y equals 3 natural log of x. Now you take the derivative. This is a constant. 3 is a constant. What's the derivative of natural log of x? We already found out it's 1 over x. So it's going to be 3 times 1 over x, which is just 3 over x. And we get the same answer. You have f of x equals natural log of x minus 3. How do you find f prime of x? Well, it's going to be, what is u? U is x minus 3. What is u prime? It's just 1. So it's going to be 1 over u, which is x minus 3. So that is f prime of x. Now, what will be the domain of f prime of x? The domain is all real numbers except what? Except x equals 3. Because when x equals 3, denominator becomes 0, so f prime is undefined. So domain of f prime is all real numbers except x equals 3. If you have y equals power of radical 2, in order to find the derivative of this, all you got to do is apply the power rule. Because this is like y equals x to the n. And what's the derivative of that? It's just n times x to the n minus 1. So it'll be radical 2 times x to the radical 2 minus 1. That's it. You don't have to do. You don't have to go further. So let's find the derivative of this. It will be y prime is pi times the quantity 2 plus sine 3x to the pi minus 1. But we're not done yet because we need to find the derivative inside. We have this rule called chain rule. So what's the derivative of that? Derivative of 2 is 0. And what's the derivative of sine 3x? That's cosine of 3x. But don't forget about 3x. You have to find the derivative of 3x, which is 3. So we could put 3, multiply 3 with pi, 3 pi quantity, 2 plus sine 3x to the power of minus 1, and then cosine of 3x. If you have y equals x to the x, where x is greater than 0, how are you going to find y prime? First of all, don't do this. Don't say it's x times x to the x minus 1. This is wrong. You could only apply power rule when you have y equals x to the n, where n is a real number. Here we have a variable to variable. So what you need to do is you first need to natural log both sides. And when you have a natural log, right, the exponent goes in front of natural log. So you get natural log of y is x times natural log of x. Now remember, our goal is to find y prime. So how do you find the derivative of natural log of y? We have to use implicit differentiation. What is the derivative of y? It's going to be, remember, derivative of natural log of u is u prime over u. So our u is y. What is u prime? That's y prime, isn't it? So you're going to get y prime over y equals, we have to find the derivative of this. Using the product rule, you're going to get x times derivative of natural log of x, which is 1 over x, plus natural log of x times the derivative of x, which is just 1. So you end up getting y prime is 1 plus natural log of x times, I'm going to move y to the other side, you get y. So which is y prime is, what is our y? X to the x. So y prime is equal to quantity 1 plus natural log of x times x to the x. Let's say you got p of t equals 100 over quantity 1 plus e to the power of 3 minus t. How are you going to find p prime of t, which is the same thing as dp over dt? Well, first, let's rewrite this as, you could apply quotient rule if you want, but I prefer to rewrite it like this. And then apply the chain rule. So if you apply the chain rule, Negative 1 times 100 is negative 100. Quantity 1 plus e to the 3 minus t. And then subtract 1, you get negative 2. We're not done yet. Times the derivative of inside, which is, what's the derivative of 1? 0. And what's the derivative of e to the 3 minus t? It's going to be derivative of 3 minus t, which is negative 1. E to the u, which is 3 minus t. So you get, negative times negative is positive. You get 100 e to the 3 minus t times the quantity 1 plus e to the 3 minus t to the negative 2 power. Now, if you want to change a negative 2 to a positive, this is the same thing as 100 e to the 3 minus t all over quantity 1 plus e to the 3 minus t to the second power. So this will be the derivative of p of t.